And good evening, everyone. Welcome to a new virtual DDD meetup. With me today is Dave Farley. We're going to talk some test-driven development. So, well, for the people who don't know you, Dave, maybe an introduction.
Sure. My name is Dave Farley. I'm an old software developer. I've been developing software professionally for nearly 40 years, not quite. I'm one of the authors of the book called Continuous Delivery, which talks about kind of a second generation agile process of using high levels of automation. It's kind of extreme programming on steroids is the way that I think of continuous delivery. And I am a long-time practitioner of continuous integration, test-driven development, and those sorts of behaviours, and a very strong believer, and I hope advocate for them when I can be.
Yeah, thanks. So yeah, the thing today is, it's called test-driven development, right? But I see a lot of discussions about TDD is actually about design.
Yeah.
Can you elaborate maybe a bit more?
Yeah,
why you think that?
I think test-driven development is called test-driven development for very understandable reasons, but I think it's the wrong name. I think that the value that I put on test-driven development is primarily the impact that it has on design rather than the tests. Now that sounds stupid because the tests are extremely useful to have, but if in some bizarre universe I was forced to write my code and then doing test-driven development and then throw away the tests, I'd still rather do it that way around. And the reason for that is I think to do with the fundamental nature of software. Software is fragile, intangible stuff, and it's complex and unusually fragile. There are not many things in human experience that are quite as weird as software. In a tiny error can have big consequences. It's sort of as though if you wrote a book and you misspelled one word, you'd break the book. And that's a bit what software is like. A comma in the wrong place can invalidate a whole system. It can bring it down. Small errors can have huge consequences with software. And there's not very much in human experience that is similar to that. But one thing that is accounting, rather weirdly. And accountants learned how to cope with the fragility of their thing centuries ago. So depending on where you look, it's either the Romans invented it, or they invented it in Genoa, or merchants invented it in Genoa in 1340, which is the idea of double entry bookkeeping. And double entry bookkeeping is an error detection protocol. What you do is that you have an independent path verification of your sums in accounting, and you calculate what should be the same result in different ways, and if the results agree, then there isn't a mistake in the calculation or in the addition. We have the same problem. We have just as fragile stuff, except our stuff is even more complex than accountancy. And what test-driven development gives us that is unique, I don't think there's anything else in software development that does this, is it gives us that independent path verification. We design a test, and that makes an assertion of the intent of our code. We write some code to fulfill that assertion, and at the point at which the assertion is made in the test, they meet when we run the test. And that gives us this independent path verification. So it allows us to detect mistakes in a way that not much else does. So sure, you can get in certain kinds of languages, you can get nice red squiggly lines under your code when you make a change if it's wrong. But that doesn't capture everything. Functional programmers sometimes talk about the type model being a big advantage to them, but they've still got to write the algorithm. They've still got to write the code in each of those functions, and that's got to be correct. A tiny error in the code that we write can have these huge impacts. So test-driven development gives us that. It gives us the ability to do that. And it has some big impacts as a result of working that way that allows us to get higher quality design as an outcome. One of the things that I think is that test-driven development acts as a talent amplifier, which allows us to move forward. I'll stop talking at that point now, because otherwise I'll just carry on talking all the way through.
No, I think it was a good introduction, and I see Scott Nimrod on YouTube says basically the same. Type level programming is my design tool using F#. I validate my model using tests.
Yeah.
Now, test-driven development goes into mostly you write your test first, or you define your behavior first.
Yeah.
Now that doesn't need to be so. If you're just validating your code, you can write your test afterwards. What's the problem with that?
Yeah, so testing is good. Unit testing is better than not testing. It's a good thing, but there's a big but unit testing is not the same thing as test-driven development, and that's a confusing thing, because the output of test-driven development are unit tests, but test-driven development is not the same thing as unit testing. So what do I mean by that? Unit testing is you write some code, and then afterwards you think, okay, I'm going to write some tests that verify that piece of code. And the problem with that is that you start by writing that piece of code. So now, while you're writing the code, you're not really thinking about what it's going to take to make that testable. And so at the point at which you come to write the test, you think, oh damn, I don't have access to that information that would make my life really easy if I was testing this thing. And often one of the things, so often what I see in tests that were written after the code is big, complicated tests that tend to test larger pieces of the code than test-driven development typically does. And the test is much more deeply coupled to the implementation detail of the solution, because you started with the solution. You already know what the solution is because you wrote the code first. In test-driven development, you do it the other way around. So the nicest way to describe it is red, green refactor. So red, we're going to write a test, run it, and see it fail before there's any code. We're going to execute that, and then we're going to see that it fails in the way in which we predict. We're going to predict the error message that it's going to generate. And what I do is that I usually say out loud or in my head exactly the error message that I expect to see. If I run my test and it doesn't create that error message, there's something wrong with my test or my understanding, both of which is nice to find out at this point.
Yeah, I think that's the first part you say is mostly the most important part that maybe people don't figure out yet, is that a unit is not a class. And when you see a lot of examples doing TDD, they will have a test first and then write one class. So people maybe make the mistake that a unit is a class. But you're saying, and I truly believe in that the unit is a unit of work.
Yes.
It doesn't need to be a class. It can be multiple classes.
Yes,
once, right?
and how you divide up the collections of tests, I don't really mind. I think we're probably going to get to talk about behavior-driven development a little bit. And I think that's important to discuss. But I think taking a behavioral viewpoint is a very strong stance when approaching test-driven development, and thinking, what is my behavioral intent here? And you really want to collect your tests around clusters of behavior rather than classes or functions or whatever else. One of the anathemas to me of poor test-driven development, to my mind, is tests that are named for the method that they're testing. I'm testing this method. I don't care what method you're testing. I want to know what it is that you're trying to assert. What is it you're trying to achieve? What behavior do you expect from the thing that you're testing? And you want to name your tests for that and focus your tests on that, and so on.
And do you think that's why people get locked to you're saying at the start, right? If you write your unit test after, you're getting locked into your one-on-one class. And if you do TDD wrong, so you get the same results.
Yeah. I think
it's not about TDD. It's about your thinking of what a class is.
Yeah, but I think it goes deeper. So the test after goes deeper than that, because not only are you led by your solution, but you're led by the implementation of your solution very often. I have a test-driven development training course, and I've got some good and bad examples of code in the training course. And one of the examples is taken from Jenkins, which is one of my favorite open source examples of bad testing. and there's a test in Jenkins, and it's something like 150 odd lines in this one test method, and it breaks encapsulation. There's a method that is added solely to support that single test, as far as I can see in the code base. So you break encapsulation, you couple your test, you make your test much more complex and much more fragile as a result. And the anti-pattern with that test after approach that I have seen many times is that the first thing to say is, as I said at the outset, having tests is better than not having tests. So the code works because it was tested, but what happens over time in software of any complexity is the tests and the code are so tightly coupled that they end up being welded together, and it becomes more and more and more difficult to make any change. You change something in the code and it breaks a whole bunch of tests that you didn't think were related, and and then you've got to change the tests to match the code, and that's a big problem. And it's a very common problem that people use to critique test-driven development. They say that test-driven development stops you being able to change the code.
Yeah, but I was about to say that.
Yeah, but that's not really the case, to my mind. If you do genuine test-driven development, it forces you to decouple. It forces you, because you don't know what how your code's going to work yet. So the way in the red stage, at the point at which you're creating that failing test, the right mindset, to my mind, is that you want to focus on really the public exposure of the behavioral intent of your code. What you're trying to capture as you write the test is the behavior that you would like your code to express, but from the perspective of a consumer of that code. So what that kind of forces you to do is it kind of strengthens the idea of design by contract. You're designing the public API to your code in order to make your life easier as a test writer. So you're writing the test, and in the exercise of writing the test, you're focusing on making a really clean, elegant, simple interface to the behavior that you want of the code. What that does is it tends to make you design from the outside in, and it means you are putting yourself in the mindset of a consumer rather than a supplier of the code, which means that you tend to get cleaner interfaces, better abstraction, more information hiding, all of these good things with respect to the code and the test.
And that is possible, but I also hear the issue is that it doesn't guarantee an ideal design, right? You can use it to drive your design, but I've always seen people doing it and say, well, I put my code in this big 50 line of code interface, and it works. So it doesn't drive design. So at one point, what's your heuristic? Because the next part is refactor, right? Yeah. For that refactor stage, you still need to know proper design or proper decoupling.
Absolutely. And I would argue the reverse is that if you follow genuine test-first, test-driven development, that's redundant. Test-driven development is always test-first. So if you follow test-driven development, then I think it has this impact on your design. So we're going to start off by writing our failing test. We're going to think only about the behavioral intent of our code. And we're going to try and capture that as simply and as clearly as we can. Now, we have to be dumb to make our life more complicated at this point. So we're going to try and make our code, we're going to try and make our life easy by making our code easy to test. So what what are the properties of testable code? That's an interesting idea. First, let me talk about 5 properties that I would consider to be hallmarks of high quality software. So what do we count as quality in code? If we're looking to have an impact on quality, it's good to have figure out what it is that we want to achieve. So I would argue that quality code is modular, it's cohesive, it's got a good separation of concerns, it exhibits information hiding or abstraction, and it's appropriately coupled. It's loosely coupled where it can be, and it's coupled to the right degree. I think that nobody's going to argue with those 5 things. You might think of other things, but nobody's going to argue with those 5 things. And it doesn't matter what technology you're talking about. If you have 2 systems, one of them has loose coupling, good cohesion, abstraction, modularity, good separation of concerns, and another one doesn't, the one with those things is better. I think we would all agree that that's true.
Yeah. So you still need proper engineering practices, right?
Absolutely.
So similar if you would do Scrum in a development thing and you don't do any proper engineering.
Absolutely. And I consider test-driven development to be one of the few practices that genuinely counts as engineering in our discipline, in that it amplifies the quality of our output. There's not much else that I can think of that has that kind of impact. So going back to the testability of the code, if we're trying to, those 5 things, how do we put those 5 things into code? In the absence of test-driven development, the only thing that we do is it's kind of the skill, integrity, commitment of an individual programmer. It's a choice. It's down to somebody deciding whether to do that work or not. In test-driven development, we start the other way around. We're going to write the test first. And as I say, we have to be stupid to write a test that makes our life harder. So we're going to try and make our life easier by making it easy to write the tests. So what are the properties of testable code? What does testability mean? Well, we've got to be able to get into the seams in the code to be able to collect responses, evaluate the changes in the code. It's no good having a class that creates all of its dependencies because we can't see what it's doing with the dependencies. We need to invert those and do dependency injection in order to be able to see what's happening with those dependencies. So we need to get into those sorts of things. So we create this code. So what are the properties of testable code? Well, it's modular. It's got a good separation of concerns. It's cohesive. So that we can kind of test things simply in one place. It's information hiding. It's hiding the detail of the implementation from the test. The test is just explaining what it is that you want it to achieve, not how it achieves it. And it's loosely coupled, ideally, or appropriately coupled with whatever else. Those are the hallmarks of testable code. So I believe that test-driven development acts as a kind of talent amplifier for developers. It turns up the volume on how good you are. It's not going to make a crap software developer great, but it will make a crap software developer better, and it will make a great software developer greater. I have a very good friend, and we work together in a project building one of the world's highest performance financial exchanges. And my friend Martin he's one of the best programmers in the world. He's widely recognized as one of the best programmers in the world expert on high performance systems and concurrency, Java. The people that write Java take his advice on design and stuff like that. He's a fantastic programmer, and I've known him for many years, and he's always been a fantastic programmer. But I taught him to do test-driven development, and he and I both think that he's a better programmer as a result of that. He was already a fantastic programmer, but now he's a better programmer as a result of doing these kinds of things. So I think it kind of turns up the volume on your talent. Whatever level you're at, it's going to make you produce a better output. And there aren't too many things that I can think of in software development that achieve that.
Yeah, good. I agree, by the way. But so it's an amplifier. It doesn't make you it doesn't make you
There's no
a
silver
good
bullet.
developer. It amplifies your things
Yeah.
that you're already, or it can amplify, of course, the things that you're already doing wrong in your coding your tests. Right? It's what we said before. If you're wrongly think about a unit test and you start doing TDD in that way, you're actually making it worse. But that's what a lot of practices, I think, in engineering, software engineering, that is.
I think that's true, but I think what it does is it kind of puts a pressure that just leans you in the direction of tending to do the right things rather than the wrong things.
Well, if your concept of a unit is bad, then you're gonna amplify coupling the code to your wrongly picked units.
I've not seen anybody that did test first where the test first didn't force them to try and address that kind of problem. So one of the things that I talk about when I'm teaching test-driven development is the relationship between kind of the code, the test, and the programmer. And there's kind of this little dance, this little triangular dance between all of those things. The red-green refactor pattern is the refactor step is really about reflecting on what all of the stuff that you've just learned means. You write the test and run it to see it fail. You write the minimum amount of code to make it pass so you get back to a stable point. And then you take a look and you think, well, how can I improve this? How can I generalize this? How can I make the whole thing better? The tests cleaner and more expressive, the code more general and more elegant while I'm in a passing state. And that gives you this kind of tool, a workbench almost, to kind of start improving things. So absolutely, you've still got to have skill and talent and inventiveness to do a great job, but it gives you this workbench on which you can carry out that change. And the relationship between I talk about it listening to the code. If you're finding it difficult to write a test, that's not telling you about the test, it's telling you that your code is bad. And at that point, you try and start to think about how you change your code to make it easy to test. And that's going to lead you in the direction of writing more modular, better cohesive, blah code.
A lot of people also agree. I don't think, so Christina's saying, I think it makes you a better developer because you think more about design. And Theo says there's also a nice psychological effect of TDD. You have to think of intended behavior first.
Yes.
And a lot of these opposing statements against TDD is mostly a test after mindset.
Yes.
Now, coming to the question from Michael, who goes into that, and we were before it started, we were talking about the webinar with Martin Kent Beck and DHH, right? And TDD is dead. That was the statement. Yep. And you were saying, well, I wanted to be there and started ranting a bit. That's what you say, right? But do you think it was just a case that he hadn't seen the right examples, DHH in this case? Is it possible to do bad TDD? So yes, I think you already answered that. Yes, it's possible to do TDD, but why do you think that you hadn't seen? Do you think he hadn't seen the right examples, or why do you think he saw? Well, he's not here, but what's your?
I am nervous of speaking on his behalf, and
I can imagine.
And I can't talk to his experience, but talking from my own experience of seeing lots of people try and adopt TDD and get it wrong as well as get it right. I think that the traps are what we've already talked about. And this was one of the, so I was involved in the creation of Bdd to some small degree. I was in the group of people that invented Bdd, and I was kind of at the edge of it and talking to those people about it. So I didn't do much of the work, but my thinking was kind of part of the conversation that was going on at the time. And the reason why Bdd was invented was to try and get people to learn TDD more effectively. It wasn't invented for what it's turned out to be these days. It was a better TDD was what Bdd was invented to be. And that the way that I talked about it so far, talking about focusing on the behavioral intent of the code and all that kind of stuff, are Bdd ideas really. And the reason why I raised that is because what I saw over, and we saw at ThoughtWorks in the early 2000s, teaching people to adopt test-driven development, was nearly everybody got it wrong to start with. So nearly everybody looked at what we were doing and what we were describing. They say, oh yeah, I see. What you're talking about is having loads and loads of tests. So coverage is really important. And I can't, all this test first stuff, I can't imagine how that could work. So I'll write all the tests afterwards. So nearly everybody, that's what they got. They thought that coverage was important and that unit testing afterwards was just as good as writing the test before. And so they ended up writing systems that kind of welded themselves, concreted themselves together so that they couldn't move. And I think that was, to me, that's what, in part, what it sounded to me like DHS was talking about in that famous conversation. The other part that he was talking about, I think I probably just disagree with, but he was talking about the impact that it had on design and the fact that it created this big, the way that these are my words, not his, but a big surface area. You end up with lots of small pieces, and so you kind of the design kind of devolves into this amorphous thing. I've had a version of this conversation with a friend of mine, Michael Feathers, and he talks beautifully about the kind of the surface, the idea of the surface area in the code base. There's kind of, I think it's the wrong model to aspire to fewer pieces is wrong, because what that ends up is you end up with bigger, more complicated pieces. Having systems built out of many small, easy to understand and well-tested pieces is not a problem to my mind. So certainly you need good design thinking. You need to think about where the lines, the boundaries in your system are, and you know what's a bounded context and what's within that one boundary and not in another. All of that kind of good stuff. But it's going to be made up of lots of little pieces, and the impact that test-driven development has had on my code is that I very, very rarely write a function that is longer than 15 or 20 lines of code. It's nearly all shorter than that, and a class of a handful or two of methods. To the extent where when I don't build commercial software very much these days, but when I was building commercial systems, one of my continuous integration things was to do a coding standard, assert my coding standards on commit, and I would fail any method that had more than a few parameters, more than 15 lines of code, or a class that had more than 10 methods in it. And I would fail my build on those criteria because that's the kind of code that it ends up with. So I tend not to end up with huge, monolithic, massive pieces of code because I decompose things into smaller things. What that means is one of the design approaches that I believe in very, very strongly is using separation of concerns as a guiding principle. I think getting modular code, appropriately modular code and cohesive code is tricky. Focusing on separation of concerns is a great way into those two things, and it's a good direction into creating high quality code. So people worry about this kind of stuff, of these many small pieces. As I said, I spent the latter part of my career when I was building systems, building very high performance trading systems, world class high performance trading systems, and that's what the code looked like. It was small and simple, because that means there's less room for complexity to hide.
As long as you have the right cohesion and design. Yeah.
You've got to get those things right. You've got to take design very seriously to do this. And I think that's a stronger statement of quality in design than having a big piece that you can call a customer service or something, whatever it is. I don't know.
Yeah. A microservice, right? So going into a few questions here, they're starting to pop up, a lot of them, but a few go into the different styles of TDD and the difference between test-driven development, test first, and the difference between outside in and inside out. I think that's a difference also between London and and Chicago or Detroit wasn't there directly. Maybe we can go. Can you explain a bit more what you know about that and what your favorite style is? Is it inside out?
Sure.
Woodworking?
I don't think that they are quite as distinct as some people seem. At least in the way that I approach it, is that it's kind of a little bit of a mix and a match. But I suppose I am firmly in the London school. Again, that was one of the things that I was around when it was created. The way that people talk about it and describe it usually is, as you say, it's kind of bottom up versus top down. And I think you pick which one of those is the starting point contextually. It depends on what it is that you're working on. So the bottom up thing, sometimes the Detroit model, the Chicago model is described as kind of focusing primarily on state. So you start from thinking about a system, and you write your test to express the state that the system is in. I don't like talking in terms of state, but that's certainly one of the three. The way that I think about it is that there's three different patterns for almost any test at the level of kind of the small tests. You're either going to do something that's going to calculate a result. You're going to, I've got an add method that takes two numbers, and I'm going to assert that I get the addition of the two numbers back. That's one kind of stateful change. You're going to change more global state in a component. So maybe I've got a file object of some kind, and I'm going to open, or a stream object of some kind, and I'm going to open the stream. And after I open the stream, it is now in an opened state. So there's some more kind of behavioral change in the state of some component that I'm testing. And then there's kind of interactions. So I'm going to do something to this thing, and it's going to do something to another thing, and I want to record the fact that it did something to another thing. And often we'll implement that using mocking and so on. The last one of those three is what people usually think of as being more aligned with the London school. The people that came up with mocking were based in London and kind of started talking about software that way. But I think all three of those different types of tests are valid based on the context of what it is that you're trying to create. The top down and bottom up thing is really about if I'm writing a piece of, if I'm writing a calculator and I want to say what's 5 plus 7, I assert that 5 plus 7 should be 12. If I'm writing that thing, then the bottom-up approach to writing that is straightforward. It's easy and useful. If I'm writing something that uses a calculator, and I want to know whether I don't need to, the naive take on the Chicago model is that if I'm writing something that consumes a calculator, I still say, if I do whatever it takes to get that to generate 5 plus 7, I'm still going to get an answer of 12. An example, let's say I've got a ledger which uses a calculator, a ledger class of some kind, which is going to use a calculator to do the calculation. A naive take on the Chicago school is that you're going to test the ledger by saying, okay, so if I add 5 and 2 in the ledger, I get the result of 12. So now you're starting to test more and more of the system. You're kind of building it up, and you're kind of repeating yourself. If you do that badly, the London school is kind of starts from the other way around and say, okay, so I'm going to start at the top from the user's perspective and think, what's the behavior of this system that I want? And then I'm going to talk about the interactions between these pieces. And as you start assembling software from the various components, instead of testing that you get the state back that you wanted, you test that it performed the interactions that you expected. So, so if I was testing the ledger in my little example that used a calculator, I'd inject a fake calculator and say, when I do to this ledger something that requires it to figure out what the answer to 5 plus 7 is, it calls the calculator with 5 and 7.
Yeah.
I don't need to figure out whether it actually gets the answer that I need. And that's part of that school. I think there's one more thing that the London School added, and I'm not strictly sure whether this is a London School thing or not, but I've always thought of it as such. And that is, you don't write a line of code unless it's demanded by a failing test. So you organize your development from the test, and you write your tests in order to be able to demand the code that you want to write.
Yeah, and that's also the other question that Jacob had is test first and TDD. Is it the same or not?
Yeah, I see no distinction. I don't think that you can call test after or test alongside, whatever you want to call it, I don't think you can call that anything but TDD. Sorry, if you're saying test after, it can't be TDD. TDD has to be test first because it's test-driven development. You drive development from a test.
Mm-hmm.
And so I think that's in strict definitional terms, and I think that's useful. I think that's a useful distinction to make because you get all of these extra properties from test first, test-driven development that you don't get from test after. One of the mistakes that people often make, though, is that test first doesn't mean that you sit there and you write all of the tests for the piece of work that you want to do, and then you write all of the code to make it pass. It's iterative, and incremental. I'm going to write a test, and I'm going to write just enough tests to make that test, just enough code to make that test pass, and then I'm going to move on and write another test, and I'm going to evolve my software in a series of small controlled steps by guiding the design from tests.
And that does also mean, if you do the outside in part, that if you start with a more coarse-grained test, right? And
yeah.
You start writing that test and you figure out, well, maybe lower, I have some more complexity. You write a lower level unit test, right?
Yes.
That's also part of that iterative style.
Yes. And my preference, the approach that I think genuinely classes as an engineering discipline for software is, I'm going to use kind of high-level BDD style tests to create executable specifications for the behavior of my system from the perspective of a user of the system. And then underneath those, I'm going to do TDD to fulfill those specifications. But it's all test-driven development. So I'm going to write the specification, the executable specification first, sort of direct from the requirements. I have an approach that we evolved when we were building our exchange, that you create a DSL that allows you to capture in the language of the problem domain these executable specifications, and then you use those to guide the development of the system to fulfill those the behavioral intent. So this crosses over very deeply with domain-driven design, because what this means is that you start. This is a tool that allows you to help to establish the ubiquitous language. So you can use the generation of that DSL to be the embodiment of your ubiquitous language in many ways.
Yeah. That's an interesting one, because you were talking about BDD and TDD a few times now. Yeah. I saw something in chat is TDD. Well, Devon said is TDD maybe wrongly named, but yeah, nowadays BDD also means given when then and not what it really is. So maybe we can dive a bit more into that. So what's the main difference between TDD and BDD? Because you were just, according to you, because you were just saying I do scenarios and then I go TDD style inside.
So I think that there's less of a difference than I think that I think that people would think that I think that there's less of a difference than most people. So as I said at the start, the way that we came to BDD was that we were introducing test-driven development to teams, and they were getting it wrong. And we'd gone through all the same screw-ups that they were going through. We'd made the same mistakes, but we were a little bit ahead of the curve because we'd been doing it for a bit longer. And so we saw all this immense value in test-driven development that was unrealized in people practicing, seeing unit testing as about coverage and automated tests. So we came up, Dan North and Chris Matz were the prime movers behind the ideas of BDD. And Dan and Chris came up with this idea of BDD as a way of teaching the real high value impact of TDD. And it works. If you approach even the most fine-grained detail from the perspective of the behavioral intent of that code, you're going to get much, much, much better tests. Now, at the time, Dan started work on a thing called JBehave, which was one of the first BDD tools, which was focused on trying to capture tests as specifications in more readable language, I guess. And the idea of kind of the natural language aspects of BDD grew out of that, I think. And I think somewhat to its detriment, that kind of took over. I thought personally, I think that was a little bit of a mistake or a misstep from the industry's point of view. But everybody got kind of focused on these higher level specifications, and then people came up with the ideas of the three amigos and the social contract of BDD, which is all valuable. It's all great stuff, but it kind of overshadowed some of the deeper, slightly more technical engineering impact that I think a behavioral focus to testing can bring. So I see this a lot in clients, is that when people start talking about BDD, they are automatically thinking of system level functional tests from the perspective of an external user of the system. Now, there's huge value in that. That's very close to the way that I talk about acceptance tests and the kind of high level executable specifications that we were just discussing. But they don't think of BDD anywhere else. They don't think about it anywhere else. But I think that if you apply the ideas of BDD whenever you write tests, there's a huge amount of value in that. If I'm writing, a test for a list or something like that, sort of unit tests for a list, I'm going to think about that, the behavior of a list. I'm going to try and record in my tests, in that fine-grained unit test, the specification for the behavior of a list that I would like my list to express. And I'm going to try to capture it that way.
Yeah, and I think you hit the nail there. And this is also my objection always when I look at BDD. When you look at domain-driven design and the ubiquitous language, so ubiquitous language of domain-driven design is a designed language together that we all understand.
Yes.
In that bounded context, right? In the boundary.
Yes.
So that also means your lower level unit tests.
Yes.
And your lower level code.
Yes.
It should all be understandable to your domain experts, which actually one time, I think 8 years ago, I had a domain expert, accountant ledger next to me.
Yep.
And he was actually challenging my unit test and then my ledger and my code. Yeah. He says, well, that's wrong. And I'm like, okay, this is great. And that's what you want. So BDD is not only on the outside, the behavior should be all the way down.
Yes, but I mean this also in a more technical sense. So I do think that there are times. So implementing software systems, there's a mix of kind of essential complexity and accidental complexity, and absolutely we want to try and separate those as much as we can. But we've got to write the stuff for the accidental complexity as well as writing the code for the essential complexity, and so we've got to be able to test those too. And I think there's a point in writing certainly big complex systems where there might be some kind of transition. Now, I'm with you. I am. I was fortunate to be one of the authors of a fairly successful book, but the book that I wish that I'd written, the book that I've always loved, is Domain-Driven Design. I think Eric's book is just fantastic. in terms of capturing what, you know, I was, when I first read it, I was going, yeah, that's what that, yeah, because it was what, for me, it's what OO meant. It's, you know, OO was about simulating the behavior of the problem that I'm trying to solve. And so I think it's really a deeply important ideas, but there are points at which, you know, that aren't part of the core domain. There's parts in the implementation of my system where it's another bounded context. It's different, and some of that might be a technical context. It might be stuff where I am thinking technically, but still, I still want to capture that from the perspective of a consumer of that behavior. And that consumer might be another piece of code or a programmer, but I still want to capture it from that perspective. And
so that's also ubiquitous language.
So it's also a ubiquitous language. It might be a different ubiquitous language in a different context. It's possible. I had a good example of this. I have a client, a long-term client of mine, who builds very big, complicated scientific instruments, and the software, the whole stack of software, from firmware up, you know, operating systems, applications, cloud-based stuff, the whole stack of software on top of that. And I was talking to one of the teams that wrote the firmware that drove these complex devices, and they said that user stories don't work for us. And I said, well, why is that? And I said, well, our story is you press this button, and then you wait for 6 hours while the system calibrates itself before it's ready for use. And that 6 hours of calibration is about 3.5 years worth of work of software development. So there's one user story because you push the button. And so they started thinking about what this really meant. And I think that one of the key ideas in user stories and, you know, analysis really is what we're really trying to achieve is we're trying to separate what from how. We want to separate what the system needs to do from how it does it. And that's true everywhere. And that helps me think in terms of the behavior of the system. Yeah. I want to describe what I want the system to do, and I want to say the least that I can possibly get away with about how it achieves that.
Yeah. And I think that's also one of the core, well, it's one of the core things of DDD, right? I just need to look at the tests and at the model, and I listen to conversation people have around me, and they should match.
Yes. Yeah, exactly.
And maybe get new insights, but I shouldn't hear different things and confusing terms.
Yes.
Yeah. So going back a bit to TDD, this was a nice thing, but there's Ricardo is asking, people often believe assert only one thing, which is a heuristic, I think, equals writing one assert statement per, well, unit test. Mm-hmm. What would be your take on that?
I think that's a reasonable guiding principle. I think, if I'm absolutely honest, I think it's probably one of those kind of guiding principles that's a bit like training wheels, that, you know, there are times when you're a bit more comfortable and happy with test-driven development that you can kind of break that rule. But on the whole, I think that's a good starting point. I think that what it's trying to eliminate is the big bloated test cases, and they're nearly always the function of writing the test afterwards. You get, in my TDD training course, I've got a nice example again from the Jenkins code base. There's one test method, it's badly named, the class is badly named, so you have no clue what it's actually doing, and it's about 150, 200 lines of code, and it's got 9 assertions, 9 different given, when, then sections in it. If you break it up, and what's clearly happened is that somebody started writing the first part of this test after the code already existed, and then thought, this was absolutely horrible to get this software up into a state where I could test it. I don't want to do that again, so I'm gonna piggyback on the cost of doing all of that work and do some more assertions. That's what you want to work against, because what that is doing, what that should be doing, what that should be screaming at you is that the design of the code's bad.
So your heuristic here is, if you need more than one assertion, probably you need to revisit your model.
Yeah. Yeah, if you
Your
need
design.
more than one assertion, I would question what's wrong, why with the code. Now, the caveat, the bit that I was talking about is that where you can break that rule is that, you know, if you've got something that returns an object and you want to assert that the object is what you want, you know, add an equals method on the object or test the fields, and having that and saying, is it the same object as I expected, as one assertion, but actually that's multiple assertions to achieve that confidence. I think that's okay. I think that's a reasonable level of, you know, verification. But I don't want to be testing all sorts of different angles from the response from my code, because that's telling me that my design doesn't have a good enough separation of concerns and is not sufficiently cohesive.
Yeah, agree. Thanks. So there's the next question about Mosen. When do you advise not to do TDD? So he has experience of implementing integration between multiple systems, which is a set of hard to predict behaviors. I spent a great deal of time to understand the way the software should behave to make the integration possible, but I finally started to implement and I moved much faster and the design became clearer and clearer over time by each refactoring.
So I wouldn't agree that isn't a time to do TDD. I would have thought that was a good time to do TDD. So if I'm integrating two systems together, I want a platform where I can kind of try out those ideas. So if I'm integrating a system, integrating my system to a system that I don't own, I want to be able to evaluate, check to see whether the system that I'm talking to behaves in the way that I expect. Writing some tests for that is a really good way to get there. The other thing is that I don't buy the idea that if you don't understand a problem, you can't write the tests. Because if you don't understand the problem enough that you can't write the tests, I don't see how you can write the code. The level of understanding that I require in order to write the code, to me, is no difference to the level of understanding that I need to write the test, because that's what allows me to understand what's, writing the test is part of what helps me to understand what's going on. But even if it's not, the level of I don't need any more detail to write a test than to write the code. What I need to be able to write the test is better organized code. And so the test can help me achieve a nicer design by attempting to test it. The times when you don't want to be doing TDD are relatively few. If you were starting from scratch, I would nearly always do TDD. The places where TDD is difficult is kind of at the edges of systems. So it's the point at which, so there's a beautiful description that I really value from Josh Graham of TDD is about creating a little universe in which you can, your software exists and checking that your software does what you expect in that little universe. So you create this little bubble in your test so you can control all the variables and kind of really take complete control of the universe that your software inhabits. The difficulty with that is that the point at which that universe touches on our universe and touches the real world. So places where you need to touch a file system, or go to a messaging system or a database or another an external third-party system are the more difficult points in TDD, I think, and you need to think about those. So as a result of that, I'm a believer and a proponent in kind of ports and adapter patterns for software development, and I use those quite rigorously in my designs, so that to the extent where I've said this over a long period of years, is that I almost never directly consume a third-party piece of software within my code. I always go through an adapter that translates that third party's behavior into how my code works, which means that there are certain kinds of third-party software which I really dislike and won't use. Hibernate is one of those for me. If people are familiar with the Java ecosystem, I don't like Hibernate because it replaces your collections. I want control.
It's a heuristic I always use. I've actually done it myself in the past because you see so many examples, but never it's a guiding heuristic again, so it's not always true, but never ever use JPA or entity framework in your domain model.
Absolutely, absolutely. You always
Except, etc., etc. There's a few exceptions, but basic rules start with that.
Yeah, absolutely, and you're right. It's a heuristic rather than an absolute, commandment.
And for the people not knowing, it was previously called hexagonal architecture, right? The ports and
Yes.
adapters. I saw people in the chat also talking about hexagonal, but they're basically the same.
Yeah, the same idea. You want an insulation point, particularly when you're starting to talk about your core domain. You want your core domain to be pure. You don't want that infected with the accidental complexity of the outside parts of your system.
Exactly.
As far as you can manage.
Yeah, there was something going back to that assertion, Devon, on I'm trying to follow the live chat as well. It's on YouTube, which is going great. But Devon said assert one thing, and I think Scott said the same. Assert one thing doesn't mean one assert statement.
Yes. That's a much shorter way of trying to say saying what I was trying to say. So yeah, I agree.
So seeing in the chat as well, Yves was saying about going from the outside in. Let me see what he said. Deep implementation details. The flip side of that is testing too far away from the SUT. Does test permutation go up? It's a balance, right? From the outside to the inside.
Yes. Yeah, and you don't want to be testing. So I am not a huge fan of the test pyramid as a guiding principle, but I think it probably is an approximate reflection on where you should end up. You don't want to have. You'd prefer to have more of the real lightweight, close to the code unit tests that you can run millions of in a matter of minutes than you would big heavyweight whole system acceptance tests that take minutes to start up and tens of minutes to run. You'd prefer to have the lightweight tests and the faster feedback. So you don't really want to be testing. You don't want to be calculating whether the difference between 5 plus 7 equaling 12 and 13 plus 12 equaling 25 at the level of your user interface. That's just data. That's the difference between data. What you're interested in really when you're testing the user interface is all the plumbing right, so I get the answers back. You're not interested in what the answers are. You test the answers somewhere else. And so trying to figure out, and there's an awful lot of art in that, getting that right. I think it's fair to say it's a preference. My preference is to slightly over test than to under test, but I do want to be cognizant of the expense of the heavier weight parts of the testing of your testing strategy. So I prefer to get the answer fast in microseconds with unit tests where I can, and I'm going to focus my tests on other kinds of things in the higher level system tests. And the way that I do that is partly the way that we've already talked about. So when I talk about this in the context of continuous delivery and deployment pipelines, what I talk about is that the commit stage in a deployment pipeline is really continuous integration primarily, plus a little bit. And the focus of that is kind of the technical evaluation, very fast feedback, high level of confidence that the code is doing what I think the code should be doing as a developer. That's the kind of double entry bookkeeping thing that we talked about earlier. The executable specifications driven from the requirements in the language of the problem domain that help us to establish the ubiquitous language are from the perspective of an external user of the system in a production-like environment, evaluating lifelike scenarios through the application. I'm not going to evaluate every possible kind of result, but I'm going to execute the overall behaviors, and that asserts that the system hangs together and works as a whole system rather than as a series of discrete pieces.
Yeah. So that it's more to think about on what level do I couple and do I test my behavior than fixating on a testing pyramid.
Yeah. Yeah.
Yeah.
Yes. I think that's right.
And is that, and that's again a question I hope we can quickly answer. I'm not sure, but what about using BDD for ports and adapters? So from the outside of the ports and adapters.
Yeah.
But then with TDD tests from your application hexagonal, especially only testing against input adapters, and no test for any class inside your application hexagonal. So that goes a bit further, I think, than my first assumption.
So could you state that again? I'm not sure I understood.
Yeah. So what about using BDD for ports and adapters with TDD tests for your application hexagon, especially only testing against input adapters, and no tests for any class inside your application hexagonal? So I think it's mostly using TDD from the outside of your domain and using, if I understand it correctly, using BDD from the outside of your ports and adapters. So you test TDD against adapters, ports.
Yeah, and I think that's saying, using slightly different language to the way that I would usually express it, but I think that's saying the same thing that I would say. So the approach that I recommend for so the stuff that we were talking about, the kind of high level domain DSL ubiquitous language kind of tests, I call those acceptance tests. And acceptance testing, like that's what I call that stuff. So the way that I describe acceptance tests is, this is part of the definitional scope of a deployment pipeline. So deployment pipeline is scoped on an independently deployable unit of software. So we're going to evaluate to the point at which there's no more work to do that this thing is releasable. It does all of the things that we want it to do. And the acceptance tests are intended to give us confidence that this is going to fulfill the needs of the user, is deployable in a production-like environment, and can perform lifelike scenarios. That's what we're going to evaluate there. In order to do that, if my piece of software interacts with a bunch of other pieces of software that are also independently deployable, a third-party system or another microservice or something like that, then I don't want to test those things. Not my job. My job is to test my software. And so I'm going to fake those things at those integration points, at the points of those ports and adapters. So I'm going to deploy my software as though it was deployed in real production, but the thing that's communicating with my software through those ports and into those adapters is a fake. That's faking out the external pieces. That allows me to probe my software and get close to the edges of my system. So one of the things that the strategies that I really strongly recommend my clients to take for that kind of acceptance testing is, you don't break encapsulation. You don't provide any back doors into the system. You're going to use the natural public interfaces to the component that you're working on, the piece of software, the independently deployable piece of software that you're evaluating, and you're going to put that under the control of this DSL that allows you to fake inputs and collect outputs. So I always kind of this mental model of, you kind of plug your system into this kind of test rig where you're going to evaluate all of these different behaviors. So I think that's saying the same kind of thing. We're testing through those. We're faking out external third parties because we want those out of the way and not complicating the picture. We might test the interfaces to those things with other kinds of tests, but the focus of these higher level acceptance tests is our independently deployable unit of software, and then we do TDD underneath those to build the smaller pieces of software and check that they all do the things that we expect them to do.
Thanks. Yeah, I think that answers it, and if not, please respond, Jacob. So before this, we were talking a bit, and we were going inside a bit again, right? Inside the domain model, there can be lots of complexity, lots of small pieces.
Yeah.
The problem here, Theo asks, is that you more easily lose the overview of the whole system and how all these pieces work together. How would you handle that? So I know you worked at LMAX, right?
Yeah.
You had a lot of moving parts. I've seen some of the talks about it.
Yeah.
How did you cope with that and handle with that?
So I think one of the tools that you used is good architecture. And so I think that architecture, So one, I think, is that the line between architecture and design is not really a real thing. They're kind of blurry boundaries that and I think that both architecture and good design are about exactly that. So if we have a good architecture and you and I are working in the same code base and somebody comes to each of us independently with the same problem, if the architecture is good and we are both familiar with it, we're likely to come up with similar kinds of answers. We're likely to decide where we would like to put the piece of behavior to fulfill that need within the architecture. So the architecture is a bit like a map of your system. It gives you some ideas about, and you can do that in, you can do that in a variety of different ways. The way that we did it, and by far my strongest preference, if you can have a preference for an architecture, because it's always contextual, it depends on the system that you're building. But we've already established, I hope, that I am a strong believer in domain-driven design. And so we want to try and divide the system up into a series of bounded contexts. We want to think about what makes sense in terms of the context of the system, and we're going to define those as service boundaries, and we're going to constitute service boundaries. The other part of the architecture that we established when we were building our exchange was we wanted those services to be kind of pure little bubbles of domain logic. So one of the great parts of the challenge of trying to write this ridiculously high performance piece of software was that conventional solutions didn't really apply. We couldn't use the conventional approach because it was always too slow. So we came up with a mechanism that meant that the system of record was the in-memory state of a rich domain model. Which meant that our whole system was composed of these little floating bubbles of domain logic, core domain logic, which was communicated between each other with asynchronous messages. And that kind of defined a clean service boundary. And it meant that we could externalize all of the accidental complexity, persistence, clustering, failover conditions. We could externalize all of that stuff, and the domain logic just needed to service a message coming in, generate service an asynchronous message coming in, process it on a single thread of a rich domain model, and pop it out the other side. That meant that we got these little bubbles, and if you wanted to do some, match some trades, you went to the order book. You had an order book, and that was, you had multiple order books that were hosted in the matching engine. So the matching engine hosted order books, and it was obvious that that's where you went. That made sense to everybody. If you wanted to look at accounts, you went to the account service, the order management system that looked after orders for users, and so on and so on and so on. So we had this architecture that kind of gave you this rough map of the behavior of the system, and allowed you to decide where you were going to put different behaviors. And I think that seems to me part of the game. It's part of the beauty. It's part of the thing that I enjoy. The part of the challenge that I enjoy most in software development is trying to come up with those sorts of structures and organizing principles that make our life easier in terms of the actual writing of the code. That's what I really love about software development. It's that exercise in trying to organize the behaviors into understandable, navigable places. The beauty of the system that we created in LMAX was that it's one of the highest performance financial exchanges in the world still, I think. It was deeply complicated. It was doing all sorts of very sophisticated things, and yet it was one of the nicest code bases that I've worked in, that I wasn't just writing on my own, for my own purposes. It's in terms of a collaborative code base that we shared in the team, best code base I've seen, and it was fantastic. And not only could we understand the structure of it, we could have sensible conversations with with our product owners and the rest of the organization, because it was a physical embodiment of our problem domain.
Yeah. And I think that's what we want to achieve with domain-driven design, especially strategic patterns.
Yeah.
Part 4 goes a lot into large-scale systems and architecture and strategic design.
And one of the ideas that I wasn't familiar with, I don't know whether it was around at the time. I don't think it was when we started building. But the idea of event storming as an analysis tool that allows us to identify the conversations between these different pieces in our problem domain, I think is really, really valuable as a technique to try and identify the structure to start with, to begin with. We did something very similar, although we weren't thinking about it in those terms. So we've got this asynchronous model of these services, and we started out with something that was kind of fairly early on, with something that looked like that. And at the time, it was one of my heuristics for the design when we were talking about it at the time, was that I wanted the conversations between these services to be in the language of the problem domain, so that the protocol of exchange of information between the services was too in the language of the problem domain. So if you described the flow of messages through the system, it would make sense to, again, a non-technical person in the organization who understood the problem that we were trying to solve. So, if we were going to place an order for a trade, we'd have a message that was place order, and it would have inside it a concept of a trade and all of those kinds of things. And that was the level of abstraction that all of our messages were captured. There were no technical messages that said, put this in this row in a database or anything like that. All of that stuff was encapsulated. Yeah. So the services were rich domain models, and the conversations between them were kind of messages that somebody that understood the problem domain could understand. Of course, they were technically represented as binary messages, but the semantics of the conversation was also a domain modeling problem.
Yeah, and I think that really goes well into this conversation, right? TDD also as a design tool, but you need still higher level design and architecture to properly work and connect that with your problem space.
Yes, it's one of the things that, as a grumpy old man, I complain about often, is that in our industry we spend an inordinate amount of time arguing about things like languages and frameworks, and all of that seems almost irrelevant compared to the design and the quality of design to me. I don't really care whether we implement the implementation deal of whether it's a functional solution or it's using I don't know, React or Angular JS. None of that stuff matters I don't care whether it's in Java or C++ very much. Those things are kind of secondary to me compared to the importance of the kind of stuff that we're talking about in terms of the design and the separation of ideas in our solutions. That seems to me of much more profound impact on the quality of our work.
Yeah, also, of course, a lot harder because, well, you need your domain experts for that design. And I can choose my own language, so as a developer. But I totally believe in that. So we're going around until the end. There's still a lot of questions, but I have a few more. And one goes in based on your experience, especially teaching this, which is the best way to explain people the benefit of practicing and using TDD. I think we already said a lot of that. But how can we convincing people and that are not convinced about it and think that the majority of the samples, katas we find on the internet are just so simple and we can't rely on it because it's really different from actually legacy project, right? So
yeah, and that is something that I meant to talk about earlier. So thank you for that question, because that's an important point. When somebody asked the question earlier on about when don't you do test-driven development, one of the things that I don't recommend is retrofitting the kinds of tests that we've been talking about, those really low-level TDD style unit tests to legacy code, because it's so disruptive. The output of that as a design technique is written large in the code. The code just looks really different when you've done it test first, test driven, than when you haven't. And so it's really disruptive to add that to existing code. My recommendation to introduce automated testing in those circumstances is that you start out from those higher level executable specifications that we were talking about earlier, acceptance tests, as a better starting point, or use techniques like approval testing to allow you to start to modify the code to make it more modular and break it up to the point where you can make it testable. And I think that's important. And I've lost my thread in terms of what this question was, because I went back to a previous question. Could you remind me what this question was?
Yeah. So people that seem to disagree, or they say it's hard to convince them.
Yeah.
Right. And they think the majority of sample katas. Right. 12 years ago, I did a TDD class myself.
Yeah.
And go back to my 5,000 line of code God class in my legacy code base, and oh, good luck. So I think you gave the answer. Start from the outside.
Yes.
I like to use example mapping, for instance, to what does this thing actually need to do from the outside, and stabilize the system. I think, if I repeat you correctly,
I did. There's another,
and then see what you can change.
Yeah, absolutely. And there's another couple of points that I think are worth making about the katas. The trouble with coding katas is that they're not like real code. The advantage of coding katas to teach test-driven development is that they're not like real code. So they give us, coding katas are like playing scales. If you're a musician, it's an intentionally simplified problem for you to deal with. So instead of playing something hugely complicated, you play some simple scales to kind of exercise your muscles and get the techniques into your muscle memory. Coding katas are the same thing for TDD. So I strongly recommend the use of coding katas to learn the practice, but it's absolutely true. And one of the things that I observed teaching people test-driven development is that you kind of get two different camps. If you get comparatively junior people in TDD training, there's absolutely no problem at all. They'll just pick it up. And it's not because they're clever or anything like that. It's because the senior people are sitting there looking at all these stupid little exercises about adding fractions or doing fizz-buzz, and they're saying, yeah, but this doesn't look like real code. The juniors are just doing what they're kind of instructed, and kind of doing the shoe part of shuhari, and just following the class. So it's more straightforward. So the coding katas are a really useful tool, but you're absolutely right that they don't represent the real code. But the point is that they allow you to get the kind of skills, and then you use other techniques to get to the point of being able to move your code into a shape where you can start applying those skills. And an awful lot of that is more about refactoring than it is about test-driven development. And so building up your skills around code refactoring is key. I'm sorry to advertise, but I have a YouTube channel. If you go to YouTube and search for continuous delivery, and I have a bunch of videos on a whole variety of topics, and there's a mini series of videos showing me, I went and searched for some bad code and then refactored it, and it's to the point of testability. So introducing the kind of fine-grained unit testing, and went through that exercise, and it's in 3 videos. So it kind of takes you through. So you start off with approval testing, just making sure you don't break anything. Then there's some simple approaches to organizing and refactoring the code to get it into a shape, and only then can you start introducing tests. I've done my TDD course to the public a few times, but mostly I deliver it to clients. And what I try to do when I deliver TDD training to clients is we'll go through the TDD course, doing coding katas and all that kind of stuff, but then I'll try and organize it so I get to go and code with people and pair with people in their code base, so that we can start doing the refactoring, to start shaping the code, to show them how to introduce those tests into their code base, because that's something that's tricky in its own right.
Yeah, and I think you hit the point, because once I started, I had someone next to me, I think, coding already for 30, 40 years back then. He saw me not writing a unit test, and he was like, Kenny, come. And then he showed me, and then it made sense, and it started hitting me, and it was painful, but and I do like the YouTube videos, by the way. I sent them to clients, and it's a nice resource to watch, because some of them are really short, and it's nice to just watch them in between. So especially I would advise people to get these contained knowledge nowadays in YouTube channels. So trying to wrap up a bit, I think I have one more question from the audience, and then one question to finish off. Question from the audience is, in your opinion, what is the state of our industry regarding testing generally? And what about TDD? Like, belongs to normal development, seldom, not done. So I think you see a lot of clients.
Yeah.
What do you think is the state?
That's a really hard question to answer. Like everybody else, I am the victim of my own filter bubble. So I see the world through, just my experience and perspective. What I perceive, so the first thing is the people whose opinion I respect, that talk about software development, I think there's greater consensus on what good looks like than I remember seeing before across the board. And it is about fast feedback, short cycles, small changes, controlling the variables. It's these kind of engineering practices that we've talked about. Test-driven development is one of those. And nearly everybody at some level or other buys into that. The people that that might be just that I'm biased, I'm listening to the wrong people, I don't know, but nearly everybody kind of believes that. What I see in clients is patchy. The idea of automated testing has moved on. It used to be very common to hear people saying, I'm a developer, testing's not my job, which I just think is wrong. And if you'll forgive me, a bit dumb. I think that's a bit naive view of you wouldn't hire a carpenter who said, I don't care whether my stuff worked or whether my tables worked. That would be stupid. So we do care about what matters, and testing is fundamentally part of what we need to do to get that confidence. But I think that I think it's still an awful lot of people are falling into the trap of thinking, okay, so it's all about testing, so I'm going to track coverage and I'm going to write lots of tests after I've written the code to get the coverage. And if time's tight and I'm being pressured, I'll leave the testing out because that saves time. All of which are wrong. And there's increasing amounts of data to back up the fact that those things are wrong. One of the things that I value very highly is the State of DevOps report and the Accelerate book, because for the first time we have a model that can predict outcomes. If you carry out certain behaviors, you're going to score better or worse in terms of the stability of your code and the throughput with which you create that code at that level of quality. We haven't had that kind of thing before. So that starts to, I think, gives us the opportunity, if we pay attention to it, to start moving in a healthier direction, a more evidence-based decision-making. And so I think it's mixed. What I do see is I see pockets of kind of people that are fervently, commonly strong TDD proponents in all sorts of organizations. I would say most organizations don't practice it out of the gate, but I would say that most of the organizations that we think of as doing a good job are doing some version of it in some flavor or another, is my possibly biased, but that's part of my perception.
Good. Thanks. And then to finish it off, I think we had a nice chat today, and I hope the audience got a lot of heuristics out of this. I do. But the last questions I always ask in these sessions is, what is the first thing people can do tomorrow?
If you're not practicing test-driven development, I'm sorry, because we've already talked about this, but the first thing to do is go and find some coding carters and spend the next 2 weeks, allocate 30 minutes every day to do a coding carter following the strong approach to test-driven development. You don't get to write a line of code without first writing a test that fails, that demands of you to write that line of code. Do that for 30 minutes every day for 2 weeks, and you will understand test-driven development better after that than you do now. There's a great resource for carrying out that exercise, which has a bunch of different coding carters, and it has a bunch of virtual machines where you can kind of establish a little environment in which you can do the testing. It's called Cyber Dojo, Cyber, CYBER hyphen Dojo, DOJO.org. And it will, yeah, thank you. Somebody's put the link there. So cyberdojo.org will allow you to practice these and give you some ideas about coding carters to play with. So that's my piece of advice that I would give people if they're not doing test-driven development. If you are doing test-driven development, go and teach somebody else how to do it.
Yeah. Well, I saw you talking or questioning this week about pair programming, right?
Yeah. Yeah, so, absolutely.
To link back. Well, thank you very much, Dave. And tomorrow there will be a new video out about TDD as well, I think. Yeah. If I'm correct on your channel, I will add your channel to the YouTube channel here so that people have the link to your channel.
Right.
Thank you very much. I'm going to close the stream, not the webinar, by the way, so we can talk after I close the YouTube stream. But to the people still watching, thank you again. Thank you for all the questions. There was a lot of chatting in Zoom. There was a lot of chatting in YouTube. Tonight, we'll publish our next meetup in 2 weeks, which was actually a meetup we were holding last month, which is what makes you a DDDer. It will be a panel. Will be much fun. So hope to see you in 2 weeks there. And thank you all for listening and tuning in and ask your question. And hope to see you next time. Bye-bye.